Thank you so much. I appreciate that. Welcome, everybody. I hope that through this Q&A, I can pass on some information to you that you'll find useful as you pursue your knowledge of AWS. Let me just say this, though. AWS is a really, really, really big thing out there. There's so many services, there's so many capabilities that if you ask a question that I just don't know the answer, or I don't feel comfortable that I've got enough knowledge to give you a really solid answer, what we're going to do is this. I'm going to write that question down. I'm going to keep it handy. And then through the channels that we have, I will get that answer back out to you. So feel free, ask anything that you need to ask, particularly if you're interested in any of the areas of certification. Prior to coming to INE, I worked at Amazon Web Services. I was a member of the training and certification team there. I was an instructor, public speaker, and content developer. So I know quite a bit about the whole certification process. So if you have questions like, what's the best path to take? Where should I start? Anything along those lines, feel free to ask. I will answer those as they come along. And again, that's a fairly complex subject in and of itself. So don't hold back on that. If you have some pretty serious questions on that, I'd be happy to answer them. As far as what we can tell you about ourselves here at INE, one of the big advantages that I can tell you about right off the bat with INE is this: we're not the cloud vendor. We can tell you probably more honestly than they can about a service. Now, they're not going to, gloss over things that could be problematic, but it's things that we can point out to you. Like, for example, when it comes to things like how much data you load into a particular provider, data has gravity. So you have to think about those sorts of things as you begin to use those services, because as you put more data into a particular provider, you're going to have more data in that provider. So you need to be thinking long-term about your deployment of data into any particular provider, AWS or otherwise. One other housekeeping point I wanted to make. Tracy mentioned earlier, and if you missed Tracy Wallace's, our content director, his talk on Azure, great talk, check that out. But he had also said in that I would call him crazy for saying that Azure is better than AWS. And that is absolutely right. Tracy is crazy. No, it really depends on the flavor of what you like and what you see. Both services, there's a lot of things there that you can take advantage of and can use. It really depends on which one feels best to you. Which one do you like better? Tracy made an excellent point about how it feels like with Azure, there's a little bit better on-ramp, like you can really get going, where with AWS, you get a little bit finer control, but that also means you've got a little bit finer control that you have to take into account. So it really depends on what you find easiest to use and where you really find the most use. That said, I'm keeping an eye out for any questions here, so post up any questions that you have. I'll be happy to answer them. Until I see any, though, I do want to tell you something about cloud. And I want to talk about cloud in general, and this is where INE really comes in something different, because we want you to really understand cloud and what it is and how you can use it. To that end, there is a particularly good story that I like to point out. And this isn't a made-up story. This is a concrete story. And I encourage you, if you want to see the entire presentation at reInvent that AWS had, look up Novartis AWS. And you can find out about the pharmaceutical company Novartis, Novartis, and what they did with AWS. Novartis being a pharmaceutical company, one of the things that they wanted to do was find some compounds that would work against a particular type of disease. Actually, it was cancer, I believe, that they were working against. And they had about 10 million candidates they were going to go through. Now, projecting their chief technical officer, projecting what it was going to take, they were looking at about $40 million to build out all the infrastructure that they needed, which they were looking to create about 50,000 cores so that they could loop through this work and find potential compounds to work against this particular cancer. That's a lot of money. That's a lot of time. That's a lot of work just to get to the work that needed to be done. What happened in their case, though, was they had a partner that came to them who knew a lot about AWS and said, why don't we try this in the cloud and see what happens? So they loaded up all their data, and this is the end story. Using something called spot instances, which are EC2s that you're basically bidding on to get the lowest price possible. They were able to spin up 10,600 EC2 spot instances, giving them a total available compute space of about 87,000 cores. The job took 9 hours, and from their original capital expenditure of $40 million, their final price tag on this job was $4,232. Now, this is not an AWS specific story, even though it is about AWS. For you, it's a cloud story and what cloud can do for you. Start thinking outside the box more. Think about what you can do in terms of the services that you can just use temporarily and throw away, because that's the idea of the cloud. You'll notice that with a lot of AWS services, you'll see that E letter in front of so many different services. Elastic, it's stretchable, it's malleable, but most importantly, when you're done with it, put it down, because then you're not going to be paying for services and utility that you don't need, that you don't have any use for. Same thing with Novartis. Once they knew the compounds that they needed, there was no reason to have a $40 million infrastructure sitting. They had what they needed. So think in those terms, and it can help you out quite a bit when you are working in the cloud. All right, let's see what sort of questions we have over here. Don't see any questions yet. Okay. No questions yet. Tracy, if you just pop me a ping in the chat or Q&A just so I make sure that I'm still online, I'd appreciate it. My story, yes. Yeah, Tracy just popped out the story was engrossing. Yes, it is a compelling story. There's just no doubt about it. That is a big story. So again, I would encourage any one of you who really wanted to see in detail about the Novartis story, and that's just one of thousands. And again, it's not just AWS. This is AWS. This is Azure. This is GCP. This is across the board that you see these sorts of things happening. So even though you may be looking in a space where you're like, well, we're just going to kind of go to the cloud, don't do that. Of the probably 80 plus customers that I've worked with over the past 3 years, in every vertical that you can think of, one of the biggest problems I've seen is this. They'll say, well, we've gone to the cloud. And I'll say, okay, well, tell me what you did. And they'll say, well, we kind of had an idea of maybe they were using containers, maybe a Kubernetes type buildup. And they took and they put that into AWS. Well, that's good. But here's the thing. You didn't really go to the cloud. You just put your servers someplace else. You just put your containers someplace else. The differentiator I've seen in just about every one of these cases has been knowledge. What do you know? What do you understand about cloud? And what sort of experience do you have in terms of just building up infrastructure that might be useful in an actual concrete situation? It comes down to education. So in that case, that's one of the reasons why I'm really excited about being a part of INE, because what we're really trying to do is give you that big picture view of cloud with the specifics of AWS, Azure, whatever the case may be, so that you can start understanding that when you go to the cloud, for goodness sakes, just don't forklift that workload. Really start thinking about, how do I go to the cloud? In that particular case, there's something else I wanted to point out to you that Tracy Wallace, our director of content, did yesterday, which was an overview of the well-architected framework. What the well-architected frameworks, I just got the question here, I'll come right to that. I want to talk about the WAF just for a moment. What the well-architected framework is this. Think about if you could spend a year or two going out with all the system architects at AWS, not on dates, going out with them as they talk to customers, hearing the sort of things they go through, hearing what the customers say. What you would find is that those system architects, those technical account managers, end up asking a lot of the same questions over and over and over again. That's what the well-architected framework is. It's a big compilation of questions, more than anything else, that you should be asking yourself across the 5 pillars: security, performance excellence, performance efficiency, cost, and things like that, making sure you're asking the right questions. So for any of you that are watching this, that are like really starting to ask the question, okay, Brooks, I get it. We need to move from we forklifted over a workload to really getting into the cloud. Get your hands on the well-architected framework. Now, both Azure and AWS have their own version of it. With AWS, the well-architected framework is a white paper that you can download, that you can read through. But let me encourage you, look up the well-architected framework tool. It's a way for you to keep your questions and answers, your answers to those questions online in a central location. So as you go through answering them, it gives you a better idea of what you need to be doing to really get into the cloud. Not only in terms of security, but in terms of operations, making sure you've got your team in place that really understands what's going on. Are you keeping your costs down? And are you running at the efficiency and performance level that you expect? So I encourage that to all of you online. Take time to look that up. look at those questions because it could be a complete game changer for you and your company, or just you as a person trying to build out an infrastructure to show just how awesome you are at cloud. So we have this question that just came in. First of all, thank you for the welcome. And can I describe how AWS Cloud can work in a hybrid environment via on-premise and the cloud? This is an interesting question because it actually kind of goes out in a couple of different directions. If you think about what AWS has available in terms of hybridization of environment. And again, my apologies. I wish I had a whiteboard here that I could pop up for you and draw this out for you. I'm going to do my best to try to explain it to you, just giving it out to you in words. So how the AWS Cloud can, in a hybrid environment via on-premise and the cloud. With a hybrid environment, one of the things, actually, it's interesting, the answer to this question is interesting because one of the things that I found many customers do when they first started going into hybridization was this. They had that workload up in the cloud they were using, and they had all their on-prem stuff, and they were thinking about, we've got to go to the cloud, we've got to go to the cloud. What a lot of them, their first step into that, when they do that hybridization, when they create a network using something like AWS Direct Connect, which gives you that VPN connection from on-prem up to your VPC, your virtual private cloud network up there, is they'll stand up something called an AWS Storage Gateway. Now, what the storage gateway is this, it's a way of extending on-prem storage up to the cloud. The reason this is a big deal is that because storage in the cloud is cheap. So when you start to realize that your backup space or your database space, whatever it is starting to run out before a lot of customers were ready going to jump into that big CapEx cost, what they would do is they'd set up that hybridization environment. Again, you're on-prem, hooked up via a VPN, straight up, to make that connection up. I just saw a great question come in that I'm going to answer here in just a second. To make that connection up there, so now your backup system, say it was looking for a SCSI interface, for example, the storage gateway can actually present to a system like that something that looks like a storage gateway, but in actuality, up in the cloud is an S3 bucket. So that's a great way of how you can start using AWS in that hybridized environment. Now, let me bring that back down again, though, and tell you something else that AWS can do that's really slick. If for some reason you have a workload that for whatever reason you cannot run up there in the cloud, but you want those AWS services, there's something called AWS Outpost. And what Outpost basically is, it's a rack of servers that AWS will bring to you, shove into place with the AWS services on it. So for example, if you wanted to use Lambda on-prem, whatever the case may be, you could actually run those in that environment. So it gives you that ability not only to have the hybridized environment of workload here, workload there, but AWS now has a way to bring that right down to you. Let me extend that question just a little bit, because there is a product they have that I want to talk, or a product and service that I want to talk about that for some reason was really surprising to me that a lot of customers didn't know about, but it's called the Snow family. And I'm not joking up, it's called the AWS Snow family. There's Snowball all the way up to the Snowmobile. If you have a workload or a lot of data that you need to get up to the cloud, and the quintessential case for this has been databases, you can order a Snowball. And the Snowball is basically a big USB drive that they will send to you. You plug it into your environment, you put your data on it, you send it back to the data centers, and they'll load it up for you. So in this case, it's a way from that point to start moving into that hybridized environment where we've got, say, our middle tier logic running, say it's like a C# app running on some Windows servers local, but the database itself is up there in the cloud, and this latency is okay. This isn't a thing where we need to have single-digit millisecond going back to the customer. That's a great way of building that hybridization over a VPN as well. I think the only way I could extend that question anymore is, if you haven't looked into it, I highly encourage you now. Everyone, remember what we do here at INE. We want to make you experts. To that end, you're going to need to start thinking about edge compute. You're going to start wanting to think about 5G. You're wanting to start thinking about how can we get compute not just from our environment up to the cloud, but how can we get it out to the very edge where phones are going to be attaching. Take a look at AWS Wavelength. Wavelength gives us, as developers and implementers, a way of getting that code and that compute really close to the end users. So really, to take that question and expand it out, with hybridization in AWS, it's not just, on-prem up to the cloud. It's cloud coming to on-prem, and it's all of that pushing all the way out to the edge as well. We have another question here. And the question is, which cloud is better to start with? Oh, now that's a question. That's a question. To be honest with you, there's really in the environment, if you were choosing between AWS and Azure, you really can't go wrong. Whichever one feels better to you. If you're already working for a company that is using one of those technologies, go with that technology. You just can't go wrong with either one. When it comes to Google, Google is in a unique position right now because whereas AWS and Azure are really controlling the market, and of course, AWS is just a monster in the space, Google's really getting into a place where they're going to be, I think, either moving into being one of the major providers or being one of the niche providers, particularly in the areas of AI and ML. But that said, if you're working at a place that's already implemented Google Cloud, go with that because that's going to give you that up close face work that you can do with that environment and really see where it's at. As far as materials go for learning AWS and Azure, AWS gives you and Tracy answered this earlier, so I'm going to try to mimic back what he said. But on the AWS side, when it comes to learning, they give you the free tier, which is a 1-year access to the services. Now, it does have limitations. And in some cases, that free access actually extends beyond the first year. For example, there's a lot of AWS Lambda, which is the serverless system that AWS has available. A lot of S3, a lot of things like DynamoDB. If you're not making really big solutions, you can keep those running for quite a long time at absolutely no cost to you whatsoever. Azure has a very similar setup as well, where you can really take advantage of a lot of those services, get to know them, get the hands-on with them so that you can really start to learn how they work. Just a moment. So I really don't think that you could go wrong with either one of those two, either AWS or Azure. I have a bit of a lean towards AWS. That's just personal. It's the one I've learned with. And I'll be absolutely honest with you, I am a .NET fanboy from the beginning. I was one of the early adopters for C# when it came out. It's absolutely a fantastic language. Wrote tons of code that ran on Windows boxes. But the first cloud provider I learned was AWS. I just stuck with it. I like it. I know it. It really comes down to that point of which one do you think that if you're in an environment where your company's already using it, go with that particular cloud provider. Other than that, you can't go wrong with either AWS or Azure. Absolutely nothing you could do there that'll make any difference. But I do want to tell you this. Which one to get started with my next little thing I'm going to say is irrelevant. For goodness sakes, in both cases, set up a billing alarm, okay? Now, this again is where I've loved coming to INE because if you look at either one of those providers, if you look at their materials, they're really good about teaching the cloud. I want to add to it the expert stuff. And this is something for everyone online who's watching this, maybe at some future date to get. Set up a billing alarm making a billing alarm as one of your very first things you do. You do not want to get surprised when you find out that you've installed a system up there, maybe via a CloudFormation template, via Ansible. It's got a front end on it, and suddenly it went wildly crazy. You had a scaling event, and suddenly you owe one of these providers a lot of money. So create that billing alarm. And in AWS, it's really simple. You simply go under billing, set up the alarm, and you can set it to go to your phone, to an email address, whatever the case may be. Figure out what's your maximum allowable bill. And that's actually something I'm stealing from a customer I work with. They came up with this idea called a MAB, maximum allowable bill. And they set that value up, and they set up a billing alarm that said, if you get there, let us know so that we can jump in there and find out what's going on. Now, here's the expert side of that. Do not create one alarm. You should create at least 3 different alarms. Let me explain why. There was a customer I worked with. They'd set up a billing alarm, and their MAB, if you want to think of it that way, really their run rate with AWS was $25,000 a month. They had some developers that discovered AWS Macy, which is really a slick service from Amazon. What it does is it looks at your S3 buckets. If it detects anything that looks PII, personally identifiable information, it could be driver's license information. It could be, for example, passport, what's some of the other patient-related information. And that's also customizable. It'll detect that, and alert you. It doesn't take much DuckDuckGo search or much Google search to go out there and find where S3 breaches have led to dumps of massive amounts of PII data. So they ran Macy. The thing about Macy is it can be expensive, and they got quite the bill. When their billing alarm fired, it came in just as they were having an on-prem VMware meltdown. So they kind of went, okay, we'll check that later. The thing about those billing alarms, y'all, they fire one time when you go through that particular level that you set, and it's not going to fire again. Your bill is going to keep going up, but you're not going to get a second alarm. Here's my recommendation, and I recommended this over and over and over. And in fact, this is not just a personal recommendation to you. If the organization you work at or the company you work at, wherever you're at, if they don't have billing alarms, you should start crawling the walls asking why you don't. But when they create them, create 3. Create one at about 70% of your maximum allowable budget, 90, and 100. And you should have escalation in all 3 of those. So it lets the team responsible know, the team responsible and the boss know. And maybe at the 3rd one, you might even want to let the financial people know that, so it gets as much visibility as possible. Hopefully it doesn't go to that you can catch it and deal with it. But again, from an expert level, please don't forget those sorts of things. Okay, I'm checking for other questions. All right. In lieu of any questions, for those that are listening, there's something else I wanted to talk about that I think is really important, that a lot of folks that are moving to the cloud, that they're new to the cloud, don't quite get about cloud, okay? And that's this. If you've heard the first thing about cloud, you've heard about scaling. And this is one of the best features of working in any cloud environment, and where AWS really shines. It's the idea of this. As your customer base starts to grow, your environment can scale with them. And this is what is so important about cloud. Doing this on-prem, you couldn't do it. You had to add servers to the mix, or worse, you had to have a whole lot of capacity sitting over here that you were paying for, friends, over here, just in case it did go up. Now, with the cloud, the scaling events are great, but let me tell you this, and this is what I have found over and over and over. Your environment has a very good chance of scaling when you least expect it and when you are not ready to expect it. For example, all it takes is a particular talk show host to say that your thing is her new favorite thing, and your environment blows up. That has happened. Go check out Zappos sometime and what happened with them. All it took was, this is my new favorite thing, and then they had a meltdown. And I will say this, and I don't tell the story. I'm not going to tell the story, but I actually worked with one company that had been absolutely hobbled by something that had happened to them. And so they were really dealing with the situation. The weird side of it was this: it also caused a tremendous demand in their product. When you're over here dealing with this situation that everybody's just trying to stay on their feet, then suddenly you're scaling and your on-prem environment is not adapting to handle it, that's when you're going to fall down. I cannot tell you how happy I have been on occasions when customers have written to me when I was at AWS, who've written to me and said, you were exactly right. We set this up, we figured out the scaling problem, and at 3 a.m, it launched. And there was nothing for me to worry about, and there was nothing I had to handle. It just took care of itself. And that's one of the reasons why that when you do scaling, don't think of it just in terms of we can scale to meet customer demand. But when the scale happens, nobody should be running around. Your system should be taking care of it. All right, that's great scaling. A question came in. This is interesting. Does it make sense to have an environment with both Azure and AWS Cloud for contingency, and can they play well in the sandbox together? Yes, yes, and yes to that question right there. There is quite a few customers I've worked with who said that, we're mostly here in AWS, or we're mostly here in Azure. However, we have a workload over there as well, whichever over there as well. And I would ask them, well, why would you do that? Tell me that sort of the benefit of that. And the answer has always been the same. So we understand and know that we can work in that other environment. You just never know what could cause you to go from one environment to the other. The one that I've seen more than anything else actually has been cost. It's just been cost. On one provider suddenly makes the deal the other one can't make. It's a really big savings. It's enough to overcome the cost of making the move over from AWS to Azure, Azure to AWS. And so in that case, that becomes a really good place to say, look, we've got a workload over there. We know how to work in that environment. Better than that, if you're at a large organization, you know who your system architect is. You know who your technical account manager is, so that you can quickly get them on the phone and say, we're moving your way. We're going to need some help. So and that's sort of the soft areas of a cloud that are really important that you need to build up. As far as them playing well together, that depends on you, how good a job you do. There is no doubt that if you want, just to give you a little bit of background with me, I spent the better part of the 2000s working with Exchange, working with Active Directory, and working with identity management. Matter of fact, the whole launch of the Microsoft Identity Project, which originally was the Meta Directory Meta Service, that eventually became the Microsoft Identity Integration Server, that eventually became the Federated Identity Manager. A lot of that initial sort of playing with it was done by an organization that I was with at that time. I could not recommend enough to you that in that particular case, the code that we wrote would run great on AWS, but I would be using the Active Directory services over in Azure. As far as linking those together, that's when you want to have somebody who's really good at networking, getting those sorts of environments hooked up and getting those sort of connectors happen. Now, you're going to hear from the cloud providers in this case, oh, we have that service. Oh, we can do that too. And so it's always worth looking into the native platform that those providers have. AWS has an AD platform. However, you may feel comfortable, or more comfortable, I should say, particularly if you're big into AD, with the Azure's AD, in which case to run a compute on AWS and to run the AD over here, absolutely you can do that. But I want you to, pardon me, my throat is completely drying out. I want you to think about that in terms of really smart architecture. Remember this about AWS, and this is one of the things I used just to beat people up about. Like, you're going to memorize this whether you liked it or not. API. Everything in AWS is an API call. That's why you can get to it from a web page, you can get to it from code, and you can get to it from by calling the service directly, or the command line, I should say, the command line, and then calling the service directly via something like Python using the Bodo 3 library. It doesn't really matter. If you build smart architectures that are using API interfaces, getting two cloud providers to work with one another is not a problem at all. In fact, and this is a little, thank goodness I know people well within companies, there's a couple of niche players in the cloud market that are flat out saying, we will work with AWS, we will work with Azure, and we will tell you how to get hooked up from our little niche area into those platforms. So once you start realizing that not only is it, this is something companies are going after now in the smaller markets, you start to realize just how easy this is to do. I would encourage you, particularly if you're on the AWS platform, they have a couple of templates out there that you can start to dig into. Their Git repository, as a matter of fact, has some of those in there that you can look at that'll show you how to connect those together. And if I'm not mistaken, there's even some videos on that. So check those out. Getting those two things to work together is not a problem whatsoever. Let's see. Questions. Actually, in lieu of any other questions I'm seeing out there, there's one that I got not long ago that was kind of interesting. And this is, since INE, we're so much into networking, and a lot of you out there that may be watching this are into networking. This is something that comes up to bite folks when it comes to AWS when they start dealing in networking. They get set up, they start grabbing IP addresses, and then suddenly they realize there's some IP addresses they can't touch for some reason. Now, if you know you're networking, well, I tell you what, let me assume you don't know you're networking. There are two IP addresses off the bat that you really can't muck with. And to give you a 10.0.0 type example, the .0 address is what we call the network address. So you really can't use that. And then there's what we call the 255 address, which is just a simple way of saying at the very top of your network area in terms of allowable IP addresses, that very top address, that .255, that's your broadcast address. In AWS, they reserve 3 other addresses that you cannot use. And I'm going to use a 10.0.0.0 example. Other than .0 and .255, you cannot use, using my example, 10.0.0.1. That address is reserved for a VPC router that gets magically dropped into your VPCs when you set those up. So that IP address is not available. Another one that's also reserved is the next one up, or the .2. The .2 is a DNS server that AWS drops into your environment for you as well. The last one, what a shock, the .3 address. This one has been reserved for future use. And at this time, I don't even know what that is. I never heard while I was with AWS any rumblings about what the plan was for that. However, that is what those are set up for. And if you ever want to find out more about how on earth does AWS manage to do what they do networking wise across so many servers, so many emplacements, there is a video called A Day in the Life of a Billion Bits, I believe is what it's called. It's put together by AWS. Absolutely fascinating video to watch. It'll give you some of the ideas of what they've done to make the environment happen, to make it work. I think the part about it that I've always recommended to customers is it starts to open you up to the capabilities of what you're really messing with when you go to the cloud. I've told people before, my degree is, well, my point, and as you'll see where I'm coming from, my degree is in chemistry, organic chemistry. So I've had lots of chemistry, lots of math, lots of science, the whole sort of thing. The toughest class I had was art. The reason art was so difficult was because there was no right answer. When you go to the cloud, there is no right answer. And watching videos like A Day in the Life will help you to understand, or sort of help break apart some of the frameworks you have in your head from on-prem environments, on-premise environments, about what you can really do in the cloud. So don't miss out on those opportunities for sort of self-education about what you can do in those spaces to really create revolutionary architectures for yourself, for your company, and particularly if you're in the space, because this is one I've been really interested in not-for-profit spaces. There are some great templates out there. I need to come back in a moment and explain templates if you don't know what I'm talking about. Templates out there for not-for-profits to build infrastructures very quickly in the cloud, both AWS, Azure, GCP, so they can create information technology infrastructures to run workloads at the lowest cost available and then get back out of them. And just real quick, let me come back. One of the other big powers of cloud, and this really shines in AWS, is the templatization of architecture. It's where the infrastructure as code idea comes in. It's the idea of this. I can use a declarative language like JSON or YAML to describe my entire network. And then when I'm ready to implement it, just throw it up into the cloud, whichever provider you want, and it'll build out that infrastructure for me. I'm not really getting any questions, so we may be nearing closing up here. So if that is the case, then there's something I want to point out to you. One of the most important things that any IT organization can do, matter of fact, this would probably, if you wanted to start your own consulting business, wanted to go out and make a little bit of money, this is one of the things that you could do to really differentiate a lot of organizations that are doing okay in IT to the really, really, really good companies that really know how to do IT. It's templatization of architecture. Now, if you're thinking in terms of just, okay, that's great, Brooks, so I can quickly build up a framework, you've missed the point. Frameworks mean now this: you don't have me sitting at a keyboard typing stuff that I might get wrong, okay? What it means is this: we've created a template, we know it works, that's what I'm gonna run in the environment, and I should get out exactly what I expect, so the environment looks the way I expect. What that also means is this, and this is the one thing that a lot of people miss. When it comes time to document your network, that is your documentation. If you've ever worked in the government space like I have for quite some time, we always got set in these positions where we needed to create a big PowerPoint, or not a PowerPoint, but I forget exactly the tool we were using, but basically we were trying to build out a map of the infrastructure. And we had Excel spreadsheets, we had database dumps telling us where everything was, what it looked like if we built out in this environment. That does not work. Okay. Yes. Thank you, Tracy. Vizio. Completely forgot. In fact, Tracy, I still have a copy of that Vizio. I'll show you sometime. It runs 12 feet in length. It's absolutely ridiculous, sir. But here's the thing about that. That 12-foot Vizio diagram, everybody, that explains the network is garbage. And this is why. This is not necessarily what's out there. This is what I put into Vizio. When you start templatizing your architecture, and that's how you build it, that becomes the network. That is the definition of your network. Not only that, and this is something I worked on with a government agency, not an intelligence agency, I still can't mention them, but with a government agency nonetheless, where their infrastructure did not exist at all until data got dropped into an S3 bucket. And until that data was in that S3 bucket, they weren't even sure what architecture they needed to build. There was actually 3 options that we looked at that could be necessary for any whatever data we were going to drop in there. As soon as that was dropped in there, we fired a Lambda, which is a serverless way of executing code, which analyzed the data. It built the infrastructure. The infrastructure analyzed the data, put the answer into a report bucket, and then at the very end, when that report dropped in there, the teardown Lambda fired and tore all of this down, which means their environment only existed as long as they needed it. And then once it was done, you get rid of it. And that's the point of the cloud. For goodness sakes, you should not have infrastructure sitting out there just boiling. There's no point to it. Build it up, use it, tear it down. Now, there are environments, I hear what you're saying, where you say it's got to run all the time. Yes, I get that. But I want you to start exploring those places where you can be more dynamic in the cloud to tear things up and put it down. If we don't have much more in terms of questions, let me just finish out with one big piece of advice I would give to everybody. And it's the reason why I wanted to tell you about templates. If you've never heard of a game day, for goodness sakes, you need to be doing a game day. All a game day is this. Because you've templatized your environment, this is what you can do. You can build up an exact replica of your real environment, your production environment, okay? Then what you do is you have somebody sneaky, like say somebody like Tracy Wallace, sorry, Tracy, come in and break the thing. And then what you tell your team is this: hey, the test environment just broke, or what we actually call the run environment, or the play environment, or the run day environment, call it what you want, has just been broken. Let's go see if we can fix it. The reason that is important is this: if you have the grade that I have, I can tell you when systems break. They don't break at 8 o'clock on Monday in the morning. They do not do that. They break at 5 o'clock in the afternoon on a Friday. They break right before Christmas break. That's when these things break, okay? You do not want to find out that you're not ready to handle a problem at that point. That's when you want your team to be able to go, we've done this. They know where to go to get the documentation. Oh, and they know the documentation is up to date. Why? Because just a few weeks ago, they had a game day and they realized, oh, this is out of date. We need to get the current documentation. They know where to find the documentation. They know how to log into the systems to figure out what's going on, and they can effectively fix the problem versus running around for half a day in an absolute panic. Not to mention, it will do your heart some good, folks, that when things like this happen and whoever it is, the boss, calls down and says, what's going on? Not only can you say, we know what's going on and the team's handling it right now, but because you've done game days, you might actually be able to get out a little bit of an estimated time to fix, which is an awesome thing to do. Nothing slicker than being able to say to the boss, yeah, we've done this before, we've seen it. It's going to take us about 2 hours. It's a great place to be. And without any other questions, I think I'm at the end of that. And since I've just brought Tracy out twice here, I think I'll toss it over to him. Are you there, Tracy?
I am.
There he is.
Yeah. And,
I'm sorry to have drug you through the mud like that, good sir.
That's okay. I do want to let people know that when it comes to somebody capable of doing very sneaky things with your resources, I am exactly the last person you need to worry about. Cyber people scare me. Of course, that is also exactly what somebody would say who could do that, but
Right.
true. Well, since you pushed it over to me, I am actually going to push it over to Catherine and let her wrap things up because she's going to be far better at it than I am. But thanks a lot.